The way to set this up is to look at the problem with respect to the time slots. Okay, we need, these are the number of workers, number of tellers that we need in each time slot. So we need to make sure that we are able to figure out how many tellers will be available in each of those time slots. And here we need to set up how many part-time hours will be available and how many full-time hours will be available for each of the time periods, right? So, and for that, okay, so the decision that we're going to make is how many workers we're going to schedule. Okay, so for full-timers, there's just one. How many we're going to schedule? So let's write out just that. Okay, out of this 12, how many we're going to schedule, right? So that's going to be a decision that we have to make. So therefore, that's a changing cell. All right, so that we have to stay within 12. Then we have part-timers starting, so they can start at 9 a.m. and work for 4 hours. They can start at 10 a.m., work for 4 hours, and so on. So part-timers starting, so the better, so it actually should be just that. Starting, part-timers starting at 9 a.m., starting at 10 a.m., starting at 11 a.m., starting at 12 p.m., okay, and starting at 1 p.m. So those are the start times that are available. Okay, it's given here in somewhere. So number of part-timers starting each day from 9 a.m. till 1 p.m. So they cannot start after 1 p.m. All right. So the next question, so the first question is how many full-timers we should schedule. The second question is how many part-timers we should schedule to start at each of these starting points. Okay, so that has to be changing cell as well. So with these number of tellers scheduled to start at various times, okay, then we have to figure out how many of them will be available in each of these time slots. So this will be the number of tellers starting at each of these time periods. So now we have each time slot, hourly time slot that corresponds with the requirement that we have set up. So the first set, okay, these tellers starting at 9 a.m. Okay. Now I'm going to have to absolute reference this, right? They will start at 9 a.m. and that same C22 will work till 1 p.m. Okay, they will be here till 1 p.m. and they are done. The 10 a.m. folks, okay, so they will start at 10 a.m. again, absolute reference that, and then they will go on till 2 p.m. and similarly the 11 a.m. folks, absolute reference that, they will go on till 3, and the 12 p.m. absolute reference that will go on till that, and then the 1 p.m. folks, absolute reference that will go on till 5 p.m. Okay, now if we sum column wise, then that will give us how many workers, this is part-time tellers, will be working in that 1 hour time period. Okay. Now we also have full-time workers. Okay. But you have to be careful with full-time workers, and we'll take care of that lunchtime, okay, in a minute. So here, that's your number of full-time workers. Okay, so let's absolute reference that, Now we can copy that across the board first, all the way till 5 p.m. But remember, they're going to be taking lunch break. And the lunch break is half the full-timers eat at 11 a.m. and half at noon. So that means the full-timers, 11 a.m., there is going to be only half of them present. Half of them are off to lunch. So make that into half, and again this into half. Okay. So now if you sum these two, that will give us the total tellers that will be available for each of the time slots. And the tellers required is from here. Okay. And we need to make sure that we have at least that many workers. Again, let's align this label. All right, so we must have total tellers. Let's call this tellers. Okay, and tellers required, right? Now let's look at the part-time limit. So the part-time limit is the total hours needed times the percentage limit. So that's that. Now, what is the total part-time hours? Okay. So here we have to be careful. Okay. Now here are the number of part-time workers who will be scheduled to work, and if you sum these, that will give us the total number of part-timers who will be working for us, right? Sum of these. And this times the number of hours they will work, and don't type in 4 here. We have entered that number up here, so use the cell reference. So that's the total number of hours the part-timers will be working, and we have to stay within the limit. So that's less than or equal to. All right, so now total pay, part-timers are paid $32 per day. Actually, this should not be. Okay, so that's a calculated cell, so that should not have a blue background. All right. So sum of these. So you don't sum the number of part-timers working in each hour. So that's not who's getting paid. So this is the total number of, sum of that is the total number of part-timers that will have to be paid this amount per day. Okay. The full-timers are paid, so that's how many full-timers we're going to schedule times the full-timer's salary per day. Then add the 2, then we get the total payroll per day, and let's color code that as the target cell. No, that one. So now we have the model, solver, that should be minimized, and we have 2, so that comma the next. So when you have changing cells that are not contiguous, you just put a comma and then enter the next range. The constraints are, okay, so scheduled full-timer must be less than or equal to limit, so that's 1. And then total tellers Okay, must be greater than or equal to, tell us required, add that, and then the part-time hours constraint. So that's it. All right, non-linear, non-negative, and simplex LP method. Solve, and we have a schedule, and make sure that they are integer. Otherwise, you can insert integer requirement. And fortunately for us, we have integer values. Okay, and that's our uh, employee schedule.